I thought it was going to be very exciting to work on a migration project. So when I was approached to take part in this endeavor last year, I thought finally I'm going to get to work on even older systems than I've done before. Dyalog APL is considered, or APL is considered old, but working on the mainframe is certainly bringing it back to the origins, really. So Carl and I, my associate, we've been called in to help Sandvik with their migration of CAP, which is their system. It stands for Computer-Aided Process Planning, and it helps them in planning and designing new tools for their industrial tools that they're mainly known for. Sandvik is a global company, and the revenues, our turnover is in the billions of krona. So it's a large company, and a lot of their success is thanks to automating things like designing new custom tools. So we're on APL2 version 3, which is Logon's supported APL2 version on the mainframe, ZOS 2.3, and that was the starting point, and we didn't really know much more about it than the fact that it needs to come off mainframe and onto Dyalog, either on Windows or Linux or both. Of course, we expected some language differences between APL2 and Dyalog. We knew that their user interface is using GDDM, and we've heard from presentations from Gothenburg and Volvo and Swedbank about a similar challenge with the user interface. Mike Hughes had helped them with an emulator, so we sort of knew what was coming. There are files, various mainframe file formats that they use to interact with other systems on the mainframe. The database is a DB2 database, and they also use MQ to integrate with other systems. So that's basically the background for the CAP system before we got hands-on with the code. The very simplified view of the CAP system itself, I've just marked out some components that we would need to look at. The CAP system, in addition to what I mentioned before, also has a web server to serve web clients for simple extracts of tables and ordering, configuring new tools, custom tools. So that's where we started, and we transferred the code base to Windows to get a better view of the code, because I'm not very used to the mainframe, so the text editors there were a bit clunky, and I wanted to just shift it all to Windows so I could explore the code a little bit more freely. And quite early on, we decided we would want to have some sort of a bridge between the mainframe system and the Dyalog environment to be able to exchange information and fetch data from files on the mainframe without having to do too much work. So we set up an RPC bridge to be able to make calls from the Dyalog environment into the mainframe. And to get started, we wanted to put all the source code and the history of their code changes into Git, because it would be easier to see what's happened, how active they are in making code changes, and also explore the code more easily. So having set up a bridge between the two systems, we imported all the APL2 source into Git using some existing tools like Link, but also writing our own tools to translate from the text encoding EBCDIC on the mainframe to Unicode to put it up there. Their source code management system was essentially saving a backup of the workspace and creating a new workspace for production. So we had 100 or so workspaces, historic backups that we could use as source for filling up the history in the Git repo. And then when we started converting the code to Dyalog APL, we created a Dyalog branch from the main branch and started working in our own branch in Git. And every week or so, we bring in any changes from the mainframe into our Dyalog branch to keep it in sync. And that is done in some simple steps where we use an integration branch. So keeping the mainframe version in the main branch, we have the Dyalog version in our Dyalog branch. And what I call update branch here is an integration branch where we bring in changes from the mainframe, convert them using our conversion tools, and then finally reintegrate into our Git Dyalog branch. And just to visualize this a little bit, we have the main branch with the code from the mainframe. And while we're working in our Dyalog branch, our colleagues in Sandvik are maintaining, supporting the system and making changes on the main branch. And this is just to clarify, this is just reflecting the work they're doing. They're not using Git themselves while working on the mainframe. This is just brought in for our purposes. And while Carl and I are working on the Dyalog branch, adding on making changes to work on the Dyalog platforms, their changes are brought in via this integration branch, and our tools applied to the changed files and tested before remerged back into the Dyalog branch. This has proved to be a very efficient way of working because Git is smart enough to know how we've restructured the code and how we've renamed functions. So if we make changes in our restructured code, and those originating functions have also been changed on the mainframe, it identifies conflicts and tells us to resolve those, which is very grateful because we've got enough problems as it is. So Git has been a great tool and help for us. Now talking to other APLers that have gone through a similar process, we knew of language differences. And we thought, okay, there's a handful of differences to worry about. And as we looked through the code and tried to fix source code, more and more differences reared their heads. So the list got longer and longer, and in the end, we were a little bit surprised that they were so different, but QuadML did help us in this to some extent, and then the rest has been handled by creating cover functions for system functions that don't exist, or system variables that don't exist in Dyalog or return different data. And we used regex expressions to identify this in the source code because we want to be able to apply the conversion on source code that isn't fixable in Dyalog. So some functions would have an incorrect header or for other reasons an incorrect API or invalid APL name and wouldn't fix as code in the workspace. So we relied on the source files being corrected and updated using the conversion tools, whether or not they would be fixable in the workspace. So we still have the changes there on file. Another thing, as I mentioned, the user interface, once we got the conversion tools to do the grunt work of migrating the code, we wanted to be able to run the system and see what works and what doesn't work. And of course, on line 3, the user interface pops up, and we didn't have one. So talking to Aplencia about their emulator, we found that the emulator they had was a bit outdated already and didn't have support for all the GDDM control codes that they use in Sandvik. Googling it, I found that every decade or so, there's a new emulator being built for GDDM, and we found that maybe it was time for our own implementation. It's been about 10 years since the last one, so we developed yet another emulator. The advantage of just emulating the GDDM module is, of course, that we wouldn't need to make any changes to the application code. We just keep all the user interface intact, so it looks like it did before, and the users are therefore familiar with it and don't need to re-educate themselves in using a new user interface. We settled for an emulator in TypeScript, which would make it easier to deploy on the web and for the users to use a web browser or HTML renderer if we decided to go with a fat client. We believe we will use the thin client approach of serving this through the browser because it will be easier to deploy new versions and make changes to it without having to ask users to automate the download of the source code. Essentially, interacting with the databases and all the other integration points is easier done if the backend is within our firewalls anyway. So we found a couple of libraries to help us with the terminal emulation and the graphics. In addition to the front end, we have a web server on the Dyalog backend to bridge between the APL code, which was accessing shared variables, and instead tunnel it through via WebSockets to the client. And it's also managing the asynchronous communication between the client and the backend. A couple of examples of the existing system and our emulator. Thank you, Carl, for recording these. This is just to show how sexy and modern this interface is, and how efficient it is. And which one is the one on the right is our emulator, and this might look familiar to many of you. I don't know. The emulator is doing a good job here of creating panels, pop-ups, menus. But more challenging was this part where the users of the system, I don't know if you can see this very well, but they use a flowchart and draw up the flowchart when designing new product families. And in each node here, there are decisions like branches and macro calls or procedure calls where the developers can configure how a new product should be designed and produced and manufactured. So going through this flowchart editor, they then compile this into APL code, which is then used by the system. And worth mentioning, there's also support for tracing and stepping through these flowcharts, which we haven't looked at yet, but it should just work, right? Because the emulator should handle that. Right. Another challenge was the database, because they use a DB2 database, which is also shared with other systems on the mainframe. The tables they use for the CAP system is essentially inverted tables that are serialized and written to a single column in a table in the database. And they're serializing this with an IBM format called ATR, which is not something that we can easily generate from Dyalog. What they do have is support for the SCAR format that I believe Björn either invented or designed, and that makes it possible for us to serialize and deserialize on both sides of this. The mainframe side also has support for this, so we're switching the format of the serialization. The database is also using EBCDIC 278 code page, but what's implied is the APL2 quad AV characters, which means that we need to translate from that to Unicode when we read it in on the Dyalog side, and vice versa. This was a bit tricky to get right, but for many reasons. But we've got a working solution now, so we're just going to stick with it till we need to migrate the database. We've decided to just keep the database where it is because the main users are still on the mainframe. So, well, all the users are still on the mainframe. And we want to postpone the shifting of the data store to a cloud solution once we've migrated parts of this, enough parts of the system to avoid a performance hit for the users. Right. Now, moving the system out to the cloud would mean that we start to need to communicate from the mainframe and out, and that's of course a security risk. So we need to ensure that the communication is encrypted. And we found that in APL2 there's no native way to create secure TCP connections, so that's a bit of a challenge. Googling again, we found that on IBM there's this thing called ATTLS, which stands for Application Transparent TLS. And the way it works is a little bit like a firewall configuration. You have a policy that dictates which connections from what IP to what IP, or which port to which port, or which user or job should be covered by this policy. And then it's transparently upgrading any incoming or outgoing connections by triggering a TLS handshake, and it's upgrading the connection to a secure connection using certificates. And the application using or creating these sockets is completely unaware and just handles the socket as if it was any other. So the advantage of this would be that we don't need to make any changes to any existing code using TCP communication. It would just be handled by this service. Remains to be tested, but the theory is there anyway. And for the other parts of the communication, the database and the MQ integration points, there are options to encrypt this communication or rely on the ATTLS. So we believe there are solutions to encrypt all the communication going out from mainframe. Right, now cloud. We spent last month investigating how this could work in the cloud and set up a test environment for this CAP system and explored how it should or could work. What we found is that Sandvik isn't entirely there yet with cloud solutions, so their internal teams are still working on setting out the policy standards for how to deploy to cloud and how to use cloud services. And we found ourselves taking part in that work of exploring and setting out guidelines for how to work with the cloud. But they use Azure heavily, so the host, the cloud host is Azure. But if you attended workshops yesterday, and you'll probably see a few presentations on this, you'll know that there are several cloud hosts that you could use, and they work more or less the same way. So we have our Git, the source code is in Azure repos. We have a pipeline in Azure to help us with the automation. We've set up a container registry for our Docker images, and of course, when it comes to deployment, there's Kubernetes in Azure as well. Using Docker to help us with the automation and deployment to the cloud, we're still learning, but essentially we want to go through a process of building our APL code into a workspace that we think is easier to deploy, because although you can bring in code from text files, when it's a large number of files, and this is in the thousands, it takes longer to just import it and run it dynamically. And to be able to rely on all the code being there, we prefer to actually build it into a binary workspace early on in the pipeline. And to build that, we rely on Tatan, because we use some packages. And when it actually comes to deployment, we might have other requirements. So we will need the .NET runtime in some services, the MQ client for the integration points, and the DB2 driver for database access. So using the Dyalog containers as a basis, we created our own Dyalog images, which contain the components that we require in our pipeline. So for the build, for example, we need Dyalog, the ODBC tools, and Tatan, and that generates an image which is about 240 meg. The size is important because you want to keep it as small as possible, just to reduce cost and startup time. So the smaller image you can generate, the better. And we added another image for Dyalog with .NET support, and that added another 190 meg, roughly. So you can see there's a significant size difference if you use .NET. Right, now the pipeline is using one of these images, well, the smaller one, to build the workspace. And for the actual service that we're going to provide, we need to first build the workspace and then create our own Docker image containing that workspace and all the dependencies that it has, such as assets or other files. And then finally, we push it to our private container registry so we can use it in our cloud. And just to give you a visual of that, the pipeline is essentially 4 or 5 steps where it downloads the source code from Git. It runs the Dyalog container image, and using the source code, it generates a workspace. And then in the third step, we create our own Sandvik cap image based on the .NET version of the Dyalog image, adding the components that are required for that specific service, and push it to the registry in the fourth step. And as you can see in the end, that image is then ready to be run and deployed. Now, going back to my little overview here, we have a bridge in place. What the next step would be is to get this running with the files being shifted out of mainframe and having direct access to the database for the tables that are going to remain on the mainframe, those owned by other systems, we still need to access the database. But everything that is CAP related, all the data files that are owned and managed by the CAP system, we want to shift them out of mainframe and redirect the users to go through our Dyalog version rather than the mainframe. And those boxes in yellow would be there, remaining there, so for comparison, or just while migrating people over. So we'll use the bridge to synchronize the systems or access the files from both ends. And of course, the end goal, if we're going to the cloud, would be to run these services in containers and serve the users via web interface, other systems via web API or MQ like it is today, and the data store would be in stateful containers or other hosted solutions. Right, yes, outside the mainframe. That's what I was going to say. So that's the end goal. We're still exploring and learning together with the client, because there's a lot to be figured out how best to run this. But we're hopeful. It won't be finished this year. So that's about it for me.